Hello everyone, welcome. Today we're going to do an introductory episode on the components of scientific papers. This is going to help us understand how to read scientific papers, what we should be looking for in scientific papers, what are we even looking at. Okay, on the agenda today and our introductory topic, we're going to be going over the introduction, methods, results, discussion, as well as abstracts and references. First, we're going to touch on the IMRaD format. Now, this format is standardized across scientific papers nowadays, and every recent paper will include this format, and it will include an abstract and, of course, references throughout. It's important to note that when reading old papers, you're not going to see this format. I'm going to include a chart here so we can see that the IMRaD format increased over time, and old papers often used different ways of reasoning and logic in their studies. Now, this is good and problematic, of course. There seems to be a lack of methods section in old papers. It's not as easy to reproduce the studies, which is a component of the scientific process. However, old research may not include the IMRaD formula. They include a lot of reasoning and logic and actual well thought out papers rather than the robotic format of the IMRaD formatting. We're going to begin with the abstract. This is the first part of the paper that you'll see once you go on a website or even in a journal. The abstract essentially is a summary of the paper to come. It should be a microcosm of the paper. It should be perfectly aligned with the components of the paper and convey the essential meanings of the paper. The abstract is a summary. That's all it is. It is certainly not a substitute for the entire paper. Actually, reading the abstract by itself can be very problematic, and citing from the abstract is a citation error, as we'll see in the reference section of this video. That being said, it is the most important part of the paper, because it is the part of the paper that most people will read. A lot of people decide whether or not to read a paper based on the abstract. The abstract also serves as a helpful reminder for people who have already read the paper and want to go back and refresh their memory. In essence, the abstract is an elevator pitch to try and draw people in to read your paper so it gets more traction. So it is very important, but we must remember, and I cannot stress this enough, the abstract is not a substitute for the entire paper. You cannot deduce much from the abstract. You cannot check the quality of the study. And so, as useful of a tool as it is, it's something that should be taken with a grain of salt. Do not draw conclusions from the abstract. Now for the introduction, the first actual part of the paper. The abstract, of course, is a summary. The introduction is, of course, the introduction. Largely, the introduction serves as a literature review. Now, it's really important to understand that the introduction should allow the reader sufficient information to place themselves within the context of the literature. They should understand all the greater parts of the literature to be able to deduce what your paper is saying based on the greater literature. They should also be able to assess your paper compared to the literature. It's very important to do a comprehensive literature review and not just a one-sided argument. I cannot stress this enough. The paper must be comprehensive. It must include both sides of the argument. You should include positive literature and negative literature and where your paper fits in the literature. Often you'll see positive literature to support the argument of the paper. Of course, the paper is a persuasive argument. However, we need to be objective in science and omit our opinions, something that is truly lost in science in general. But it must be comprehensive, so include both sides of the literature. If you're reading a paper and you're only seeing the positive stuff, it's likely that they're really trying to persuade you in a certain manner. In the introduction, there should be the scope. What is in the paper and what is out of the paper. We want to be clear on the scope. Again, importantly, there should be clear purpose. Why are we doing the paper? What is the aim? What is the goal? What is the reason? What is the meaning behind it? Who does it apply to? These are all really important topics that should be covered in the introduction. What is the point of the paper? Why is it worth studying? Why should this be included in the literature itself? In the introduction, we should also include the claim of the paper. What does the paper in its entirety claim? This is not a novel. We're not trying to anticipate at the ending. We want you to be clear because the reader should know exactly what you're claiming by the time they're done reading the abstract and, of course, by the time they're done reading the introduction. Another very important component is the agenda. It should be a short blurb on the methods section, the results section, and the discussion section. We should go over these briefly to introduce them. And of course, the hypothesis, a fundamental aspect of science. Very simple. If X, then Y means Z, essentially. Moving on to the methods section, and likely the most important part of a paper to assess. Fundamentally, the methods section is a set of instructions. And so with a set of instructions, you need to think how to convey the methods and materials properly, comprehensively, clearly, in a way that the reader doesn't have to interpret. It should be very, very clear. There should be a sequential order in the methods section. A clear set of instructions is what you should aim for. Other people should be able to read your methods section and conduct the scientific experiment very, very easily. That is the pure purpose of the methods. Simply, it must be clear and accessible. And really want to stress clarity here. It really needs to be clear. There should be no interpretation whatsoever in the methods and materials section. Concerning materials, they really should be going over brands. They should be going over the exact ingredients, right? You want to talk about the perfect ingredients. You want to even talk about if something is organic or not. I think that's a pertinent piece of information that is withheld in literally all studies. Even living conditions of rats and mice, right? They live in plastic boxes with artificial light beaming, right? It's no actual life to live, and this is not really controlled in scientific literature either. Another very important part of the instructions is detail. You need to include sufficient detail, right? And this is a balance that you have to strike. There should be enough detail that you're extremely specific and precise in what you're talking about, but not too much detail where it becomes boring and daunting. Personally, the more detail, the better, in my opinion, because I think details absolutely matter the most when talking about variables and hypotheses and the truth. Very easy to lose confounding variables with lack of detail. Sufficient detail is paramount. And so that's something that you should look for when you're reading the methods section. Often this is a very short section for very complex papers. Really, the methods should be the most comprehensive part of the paper, in my opinion, as to ensure clarity, as to ensure everything's unambiguous, as to ensure it's accessible, as to ensure there's enough detail, as to ensure that there's a logical sequence occurring in the method, right? We should be backing up every single step in the methods section. A true control, something that you don't see in many scientific studies. Philosophically, the control should be as close to what is natural for the phenomenon being studied. As soon as the control lacks a natural aspect, that is where it starts to fail. Right? I mentioned earlier rats and mice living in plastic boxes. There's no way that this mimics the natural environment, and this should be controlled for in the study. Right? If your control group of mice are living in plastic boxes, beamed with artificial lights, being fed a seed oil diet, which is the standard diet, includes high amounts of seed oils, how is this a valid control? Right? The diet that they feed rats, they're not native to the rats. Even in something like the isolation of vitamins, every step should be controlled. For vitamin C, for example, one of the first steps is the addition of lead acetate. Now, you need to prove that the addition of this chemical doesn't change the nature of the chemical vitamin C, right? It's something that's not necessarily controlled for. You know, how do we know at the end of the day that the structure of vitamin C actually mimics what's in the fruit or vegetable, right? There's no valid control for that. There's never been one proven in the literature, right? The control is fundamentally extremely important when it comes to the methods. And this is what you should be looking for. Is it a valid control? Are the variables accounted for, right? We want to make sure that all the variables are accounted for to get as close to the truth as we can. The more variables there are, which some may say that there are an infinite number of variables, which is absolutely valid and arguable in my opinion, you know, can the scientific method actually align with what is true, right? This is what you need to be assessing, right? Maybe at one point it does get redundant and the scientific method is overly accurate. Perhaps that's the case. However, you need to control all the variables that you could possibly think of that could possibly have any effect on the study. This is something that's not done in the methods section and in the literature in general. Now for the results section. Another very, very important part of the study. Fundamentally, the methods and the results are the two truly objective sections of the paper, whereas the introduction and the discussion are both the subjective parts of the paper. Therefore, it is most important to look at the logic and the meaning and value of the methods and the results section. Now, it is easy to lie and manipulate with statistics, and so this is what you should be looking for in the results section. There's a reason that there are triple-blind studies where the participants, the researchers, and the data collectors and analyzers are blind to the parameters of the study to ensure that the results remain objective. Something that's been a problem in science and will continue to be a problem in science moving forward. Can't stress this enough. Objectivity in the results section is an absolute must. It's not always the case, and that is the importance of reading results section. It's appealing to skip right to the discussion because it's almost lazy in a way because you don't have to actually infer, right? You just take the word of the scientists themselves. You want to be looking at the results section to make sure that what they're discussing in the discussion section, of course, actually aligns with the results of the study. So you want to make sure that it's objective here. Of course, the discussion should remain fairly objective, but it is a persuasive argument. However, I digress. We'll stick to the results for now. Objectivity is central. You cannot deviate from objectivity in the methods and the results sections of the paper. I cannot stress this enough. This is absolutely fundamental. However, it's just not the case all the time. So fundamentally, within the results, you're going to see some tables and some figures, and they should be raw data. This is so important, right? You could see tables and figures, but it needs to be the raw data. Some people discuss trends and patterns in the results section, which is fine. It's fine to point out trends and observations, especially when you start to use statistics. However, it's important to use comprehensive statistics, right? You can misguide people using statistics, whether you present it as relative or absolute, or if you present it as a percentage versus a decimal, right? There are ways to manipulate the mind and how you perceive the results in the way that they're presented. This is something that I want to talk about more in the future. Statistics are an area where the scientific literature actually is able to misguide a lot of the people, even professionals, in reading it, because mathematics, of course, are true. They are the fundamental language of the universe. However, statistics are certainly a branch of mathematics, but they become more manipulative in their nature as you present them in a certain amount of way. Statistics is a comprehensive study, and it's important to look at the results and make sure that it's objective. Statistics aren't necessarily objective, right? Numbers are objective. Mathematics is more so objective. Statistics is a branch of mathematics, and you're deviating away from the true nature of numbers and what is true and real. Even within the tables and graphics presented, there's even a way to manipulate how the graph looks. It incites an emotion, right? So it's important to look at the graphic and look at the raw data, right? Tables, in my mind, are a little bit better because the graphics can become more appealing and they can be presented in a certain way that is to move an emotion within an individual when they're reading the paper, right? So get back to the raw data. That's what's truly important. Of course, I mentioned the trends and patterns. Again, make sure that it comes back to the overall point. Objectivity is fundamentally the most important aspect of this. All of these things that build upon the objectivity are important to consider. However, if it's not objective, if it starts to become subjective and suggestive in nature, you're not at the raw data, you're not remaining objective, and the results therefore become poor. Generally in the results, we see it go from general to specific. Now, of course, this is because often the raw data is presented in the beginning, and it becomes more specific as we start to talk about trends and patterns and slight differences within the actual results themselves. Okay, and now for the discussion section. A subjective part of the paper that is the persuasive aspect of the paper. Now, the discussion section, of course, is important, but it's important to look at what they're claiming, right? This is where you start to get away from what is objectively true. Now, the discussion's aim is to convey results that are meaningful and truthful. However, we know that there are lots of vested interests in science, and this is not always the case. It's easy to manipulate the results with statistics. It's easier to manipulate the statistics with words. That's why it's important to read the methods and the results, which are objective, and then move to the discussion where you could see the author's interpretations and where their persuasive argument lies for their interpretations. So fundamentally, the discussion is the interpretation of the results. They're trying to make sense of the data. What does the data actually mean? Within the discussion, the authors should include more than one interpretation of the data. They really should be considering as many interpretations as they can fit into the paper. And when you get into the fundamental persuasiveness of the discussion section, they should be arguing why their claimed interpretation is the best interpretation out of them all. Of course, you cannot do this unless you go over multiple interpretations of the data. So it's fundamentally important to consider all interpretations. When I read the results section, I like to actually interpret the data myself. What can you infer from this data? What does this data mean to you? What does it tell you? How would you back that up? So then when you get to the discussion post, or to the discussion section, you could see if that aligns with what you were thinking. Maybe your thinking is flawed and the author pointed that out. And maybe you can interpret the author's interpretation and see how well that doesn't make any sense, and question it and assess the logical fallacies within his discussion and interpretation. So it's really important that the authors do consider all interpretations, because this is the best way for them to actually come to the best interpretation, right? If I look at the data and spend 5 minutes looking at it, come up with an interpretation and say this is the truth, well, I haven't really considered any other avenues, right? It's important for me to look at all the interpretations and then come up with the conclusion on which one's the best one and why. And this should all be done in the discussion section. This essentially is what the discussion section is. A few more parts that we'll cover here in a second. It's very important to note that the discussion is a persuasive argument. This is not something that's made up either. This is generally the purpose of the discussion section, right? To make interpretations and persuade the reader that your interpretation is correct, right? You really want to be addressing logical fallacies here. You want to be addressing the logic and the reasoning and the value and the meaning, right? This is where it happens. And this is where the vested interests come in, right? Maybe they don't consider all interpretations of the data. Maybe they omit data, right? That's a huge problem in science. That's fraud. And it happens all the time. You can see that with Ansel Keys in the 7 countries studies. Well, he actually did 20 countries and omitted 13 of them because they didn't fit his discussion. They didn't fit his interpretation or the interpretation of the vested interests, right? The idea that saturated fats is the cause of heart disease didn't align with his data. So he omitted data so that it would fit his interpretation. This is backwards, right? The interpretation in the discussion obviously comes after the results section because the interpretation should fit the results, not the other way around. That's where fraud comes in. And unfortunately, fraud is most prevalent in science. It's been happening for a long time. Louis Pasteur was a fraud and an imposter, admitted fraud. They went and looked over his data and it's fraudulent. His vaccine trials were absolutely fraudulent. right? Many farmers were coming out and saying that he injected their entire herd and their entire herd were dead and diseased, right? So I'm not trying to draw any conclusions from that here. I'm just saying that he was a fraud. It's admitted. It's documented. You can absolutely go read it. Ansel Keys was a fraud. Again, it's documented. You could see the countries that he omitted. If you look at the actual raw data of Ansel Keys' study, you could see that there's absolutely no correlation between saturated fat and heart disease. So it's absurd that all of the literature is built upon, of course, Ansel Keys' work, and we're just not looking at raw data. We're looking at his interpretation. This is where the appeal to expertise comes in. People appeal to the expertise. They think, oh, well, an expert wrote this discussion section, therefore it must be correct. That is absolutely not the case. The results are the objective part of the paper. You need to be looking at the discussion as a debate, right? It's not a fact. This is not a claim. These are not objective results. The results are objective. This is the discussion, right? Important part of the paper, nevertheless. But we need to make sure that we understand that it's a persuasive argument and that this is not objective. This is subjective. This is where we need to be actually using our brains, our mind, and logic and reasoning. Of course, in the discussion section, the authors should evaluate their own study. This is an important aspect of the discussion paper. They should evaluate their methods and their results and see where they could have done better, right? They should evaluate the logic and the reasoning within their entire study. They should evaluate even their own interpretation. Maybe why it could be wrong, where it could be proven false. Maybe the gaps in their method, right? It's very important that they evaluate their own study. This is an important part of science. We should be trying to prove ourselves wrong rather than prove ourselves right. A truly objective scientist doesn't care about the results, whether they are up to his standard or not, if they're in accordance of his opinion or not. A true scientist doesn't care about his opinion. His opinion changed with his observations and the data, right? That's what true science is. That's what true scientists actually do. And that's what true scientists don't do in the modern world, right? Scientists in the modern world are obsessed with their opinions, right? Maybe it's because if they don't, their funding will be gone. Maybe if they don't abide by what the university who pays them for their position, maybe their university will fire them. This has often been the case. You could see it in the past 4 years. A lot of people lost their jobs because their opinions differed from that of the establishments, right? This is the problematic part of science. People can't be objective in the discussion. They have to go with the crowd, right? And if you don't, I'm sure your discussion will not get past the peer review process, because the peer review process is an absolute echo chamber, right? If your discussion doesn't fit the literature, the scientific consensus, well, it won't get published. Why would the peer review process, why would the peer reviewers actually support what you're saying if it goes against what they're saying? It's going to hurt their ego. Science has no room for ego, and the discussion post is a dangerous section, very dangerous. Lastly, in the discussion section, there should be a section discussing a further study. This is kind of part of the evaluation. You should look at your methods section and think of variables that could have manipulated your results, and probably suggest a study moving forward to compound your study and assess with that variable. Looking back on your study, where are the gaps? Where are the areas that you could have improved it, right? And that's where the study should go further, right? And this is ideal science. This is ideal science, right? But this is not what's done, and this is what you need to be evaluating in scientific papers, right? If you're looking at further studies, right, go to the literature and see if you can find anything. Go and see if you can find a study that actually built off this study and this interpretation. Does it support this interpretation exactly? Are there other co-founding variables that the second study didn't actually account for that this study did? Well, if you have two studies that have different variables, different co-founding variables, how can you actually make a claim that it's correct, right? They should be building off the parameters of the methods section, not creating new ones, right? That's how studies actually build on top of each other. And this is something that's very difficult to find in the literature. Digging very, very deep into the literature, and you might be able to find some examples of this, but usually it's still pretty incomprehensive and inconclusive. And that's the true problem. It's like science is always building, right? It's always changing. And that's true, absolutely. Science is always changing as we try to narrow in on the truth. But drastic changes shouldn't be occurring, right? There should be slight manipulations in scientific studies that build upon each other so that we can get closer and closer to a specific result, to a specific interpretation, right? That is the true goal. But this is what you don't see in the modern literature. This is what you need to interpret when you're looking at a discussion section. Referencing, a fundamental aspect of papers, an absolutely integral part of papers. Some may claim it's an appeal to expertise or authority. That's fine. I'm not necessarily going to make that claim here because if a study does prove something, it's valid to cite that study as a conclusive study. However, studies are never conclusive. Go and read conclusions of studies. They will include phrases like, our results suggest, however, further studies are needed to validate this, right? That is often the hymn of conclusions in the scientific literature. We need more studies. We need further studies. Now, I agree. However, it's wrong to cite that paper as a fact, right? That's why it's important to go and read papers, because you'll see that they are inconclusive. And so the scientific literature is built upon a house of cards, essentially. That the referencing is built upon other references that should never have been referenced in the first place. And we'll go over some common errors, but essentially that's an error that's not even talked about in the literature, right? Building upon other studies that actually have no basis in to make any claims in the first place, right? There's so many co-founding variables in a study, but it doesn't matter, right? Even if the author evaluates their discussion in their discussion, they evaluate their methods and results section, and they say all of these problems, however, this is what we've concluded from this study, and another paper takes that paper and cites it as a fact, right? You could see that that's problematic because it was inconclusive in the first place, right? So we're going to go over some common errors that we'll see are very, very problematic, and what makes a good reference. First, we're going to begin with the citation bias. This is where studies often reference positive results rather than negative or neutral results. Now, this is for a few reasons. Of course, negative or neutral results often don't actually get published, right? Say you're a supplement company trying to sell your brand of supplement and you pay a lab to do some research on your supplement. Well, if your supplement shows that it's absolutely ineffective, or that there's no correlation between the positive effects that you're claiming and the results, that would be a neutral or a negative result. Well, the supplement company isn't going to pay to get that published, right? And so often you'll see in the citation bias that only the positive research gets published, and only if there is negative or neutral results in the literature, they don't cite it, right? Nobody is citing negative literature. Nobody is citing neutral literature. Because in a way, it seems meaningless, but it's certainly not. It's half the picture, right? Science is not necessarily about what's true, but it's about what's untrue as well. Next, we have the secondary citation error. This is where a reference is referenced, essentially. Instead of going to the primary literature, to the paper that actually made the claim, you conduct a secondary citation where you take a fact in a paper that was cited by another paper and cite that paper to back up that fact. However, you're once removed from the scenario. And of course, there are tertiary citations that are problematic. And the real problem with this is that, when you're citing the paper, you're not actually going to assess the paper. You're taking that claim at face value, right? You're appealing to expertise. You're appealing to the literature. Absolutely terrible. It's absolutely problematic. Secondary citations should not occur. And it's a citation error. Next, we have the backdoor invention. This, of course, is a citation error that includes a paper referencing an abstract rather than the entire paper. The abstract is not a substitute for a paper, and it should not be cited. Looking at abstract is a helpful tool. It's a summary, it's an elevator pitch, but it is not a replacement for a paper. You cannot take what is said in abstract at face value. It's important to read the entire paper. That is fundamentally the most important piece of knowledge that I could impart in this entire video is that you must read the entire paper. Citing from abstracts is incorrect. It's a citation error. Lastly, we have the fact not found citation error. This is where a paper is cited. However, within your citation the fact that you're citing, you're not actually citing something that was found in another paper, right? Say I claim that saturated fat causes heart disease, and I reference Ansel Keys' 7-country study. Well, in fact, that is a fact not found in that study. It's not a conclusion that's objective. It's not shown by the results, right? It's a misinterpretation of the study, perhaps. It can be intentional. It could be accidental. It shouldn't be accidental, of course. These are experts and authority figures that are doing this. However, it happens. Of course, the fact not found might be the most problematic because then you're just making claims that are absolutely made up, right? With nothing to back it. No science, no literature, no nothing to back it, right? So this is absolutely problematic. Avoid all of these when you're citing things. And this includes your citing papers on Instagram and you're citing papers on social media and family events to try and make yourself sound so intelligent. You pull out this, oh, well, this paper says this. Did you read the entire paper? Did you assess their methods? Did you assess the results? How many interpretations did they provide in the discussion, right? Did they just provide positive literature in the introduction? How are their references? Did you check their references? Papers have hundreds of references. How diligent are you in checking your facts, right? Did you just read the abstract? If you just read the abstract and you're coming out here and making all these claims, oh, that's the most fraudulent of them all, right? You have no clue what's in that paper. You have no clue what kind of things the author said are co-founding variables, right? You have no true understanding of science, of the literature itself. Reading the scientific literature certainly is not skimming through abstracts. And I'm sure many people claim to do that, or claim to know the scientific literature when all they do is skim the abstracts, right? The abstract is a tool. It's not a replacement. Fundamentally, that's the most important thing that I could impart here. As I mentioned earlier, these are terrible errors to be making. Of course, you want to be assessing the objectivity of the methods. You want to be assessing the validity of the results. You know, how true are the results? Have they been misinterpreted? Have they been misrepresented using statistics? These are things you need to look for when you're reading the scientific literature. You cannot take it at face value. You know, and we've shown here in the reference section how it's built upon an entire house of cards, right? The literature builds upon each other when in fact the literature is inconclusive. Papers are inconclusive. This is not an absurd thing to say. Go spend time reading conclusions in papers. You'll realize that they're all inconclusive. Their words are inconclusive. They use inconclusive words because they can't actually state this is a fact. Papers don't actually cite, they don't actually prove facts. They often appeal to future studies, right? They appeal to a few variables. And this is one of the fundamental problems with the literature. It's a house of cards built upon a house of cards, built upon a house of cards. We need to get back to what is true, what is objective. That is where true science lies. The discussion comes after the results, right? You cannot expect results. The expectation itself is problematic, right? That's why there are double-blind studies. That's why there are triple-blind studies. Triple-blind, in my mind, is the only acceptable type of randomized control trial. If it's not triple-blind, you know, you can read it and interpret it. That's fine. But I'll say if it's not triple-blind, it's likely that it's been misrepresented and very easily misinterpreted, right? So these are things you need to be looking for. Anyway, we went over lots today. The IMRaD format. We went over each section. We went over the abstract. We went over the references. Hope you guys enjoyed it. These are tools that you're going to use moving forward. We're going to reference back to these in our videos moving forward. I'm trying to teach you guys how to assess scientific literature. These are the fundamental parts of each section of papers. It's important to know this, right? You need to know what you're looking for. You need to know what you're assessing before you begin assessing it. These are the basics. I hope this was clear and precise. I think I kept it fairly concise, and I hope you guys enjoyed it. Leave me a like, comment, subscribe down below. Let me know what you think. Appreciate you guys. Thanks for listening. Take care.